Good evening. Thank you, Leaf, and the organizers for the opportunity to speak with you this evening. I would like to warn you that I'm going to talk about a topic that can be distressing, and I'm going to show you some images that are pretty unappetizing. Hope you're mentally prepared. Okay, let's get started. I feel guilty. Every day, I feel guilty about waste. It is everywhere. Personally, I create so much of it. Every day I go to work and order lunch, and every day it comes in a ridiculously wasteful plastic bag. When I ride on the airplane, I wake up to this meal, and I can tell I'm not alone in my guilt. Our lives are full of graphic symbols and inaccurate labels to make us feel less guilty. We pat ourselves on the back to just get the waste in the bin. But where does it really go? I needed to find out. In 2018, my company and I began to work on the problem of waste. We are a landscape and architecture studio called Ballistic Architecture Machine, or BAM. We are architects, landscape architects, artists, designers, and we try to be good business people. Our studios are in Beijing, Shanghai, and New York. For the last 15 years, we have designed parks and pathways, plazas, play courts, waterscapes, neighborhood parks, amphitheaters, landforms, slides, playgrounds and canopies, facades, tea houses, waterways, parterres, gardens, and allées. Why should landscape architects deal with waste? It's a good question. Why is it even remotely our responsibility? To answer it, I want to go back to Frederick Law Olmsted, also known as the father of American landscape architecture. I want to look at a project we all know, Central Park. What you may not know is that the existence of Central Park and Olmsted's design justification is a direct offshoot of the sanitary movement. The sanitary movement was a public health approach that developed in England in the 1840s to promote health and cleanliness. Its agenda included building sewage systems, paving streets, providing clean water, and collecting garbage. This is a quote from Olmsted's writing in his book called The Highest Value of a Park. Parks are now as much a part of the sanitary apparatus of a large town as aqueducts and sewers. Their management should be as much a matter of sanitary economy and as rigidly subject to sanitary tests. As the United States' first great urban park, Central Park was conceived as the lungs of the city and built in 1858 as an oasis for the sanitary advantage of breathing. We associate the natural image of the park with our job of landscape architecture. But we should not forget Central Park's raison d'etre, solving humble problems of urban sanitation. So, Central Park, and even the foundation of landscape architecture as a profession in the United States, was born out of the sanitary movement. What of our purpose? For landscape architects, I question if nature has become an ends in itself. Have naturalism and design with nature distracted us? We have to admit there is a contradiction here. Our naturalism requires manuals, learned gardeners, continual maintenance. If naturalism takes so much work to get right, are we pursuing the right idea of nature? This is a quote from a thinker called Timothy Morton. The concept of nature has obviously not served us well. If it had, we wouldn't be here. Here, meaning planet Earth, at this moment, the moment of global warming. If so-called nature and its balance and wisdom had been something that really functioned well as an idea, there would have been no way we would have burned all those fossil fuels and endangered all life on Earth. When we say we love nature, we mean idealized wilderness. We take out the asteroids and earthquakes. This selective editing is a problem. When we say we can achieve ecological balance through the wisdom of nature, we are also avoiding the dirty, violent, and disturbing parts. Ecological balance is a myth, and it has frustrating implications. Almost everything we do as modern people living in cities is essentially counter nature, and thus, many of us feel guilty. Waste is perhaps the guiltiest part of the balance myth. In the idealized nature, waste and decay can become a layer for renewal. It becomes a beautiful cycle. But when waste is unnatural, it cannot be accounted for in an ecological balance. We are collectively avoiding the problem of waste to the point where we don't see it as part of nature any longer. We avoid the problem of waste, but frustratingly, the waste stays with us. We have rays of hope like compostable plastics or plastic-eating bacteria, but these are suspiciously funded and supported by the corporations that wish to make us feel more comfortable consuming. The hard truth is that waste production is accelerating, and there is no ecological balance that accounts for this. We must meet industrial consumption with industrial-scale waste solutions to achieve any form of stasis. To conclude my rambling introduction, I want to point out that trash is considered by world's governments as a renewable resource. That's right, trash, an unending stream of materials and energy that we extract from the Earth's crust, is a renewable resource. Now I'm going to take you through 3 trash projects in which Bam and I have tried to take on some aspects of the waste problem. This is the first project. It's called Baoshan Waste-to-Energy Plant. Our first opportunity to work on a waste project came in the form of a waste-to-energy plant called, or what we call a WTE. WTE definitely has flaws. It is not an ideal solution, but this is a topic for another talk. Simply put, waste-to-energy works by burning the trash and using the heat to spin turbines which create electricity and transfer the heat into municipal heating infrastructure. We found a client who offered to have us design the facade of a new WTE for a competition. Although we saw these as urban landscape design problems, the client gave us a facade project. We said, okay, we'll give you a facade. So on the left you can see the preliminary input, and the right you can see the site. So, of course, we started with Central Park. We came back and said, this building does not look like a trash plant. It's going to need to be a park. We will reuse industrial structures on the site and add the new plant under the park. And we won the competition. After we started working on the park concept, we added an educational component. We wanted the people of Shanghai to come to this building to see what happens after they toss their garbage. We started to envision a mini city of programs, a museum of waste. We want school buses with loads of children from all over Shanghai to visit this site. So we organized the typical plant architecture to integrate 3 exhibition halls and a long glass hallway where guests can walk the length of the plant and observe the entire process. Our Museum of Waste starts, as all good natural history museums do, with dinosaurs. The compression of heat and organic materials creates fossil fuels, which we begin to extract and exploit not very long ago, which today we are continuing to extract and exploit at accelerating rates and produce more petroleum products than ever before. We are moving towards the future which may or may not resolve our tenuous relationship with our biosphere. From here, the guests enter a long section of the plant and witness the trash arriving and the waste-to-energy process firsthand. And this is what it actually looks like. The plant has been operational since June 2023, and the plant is still being built, although parts of the project are still being built into 2024. This is where you see 150 trucks each day driving in to drop off the waste. This is overlooking the control room where the engineers monitor the plant. And this is back at the entrance of Exhibition Hall number 1. And this is a view of the protruding exhibition hall volumes connected by elevator and catwalk. To understand how the plant works, let's look at the master plan first. The park idea is overlaid over 2 plots. They're both 35 hectares, and the north plot contains the WTE. The roof has a long span area over the bunker and incinerators, which must be lightweight. But much of the roof was designed to hold up to 1.6 meters of soil. You can also see large voids which meet fire and ventilation requirements for the plant below. Under the roof, you will see the workings of the plant, but it's a bit hard to understand and plan. We will talk about this a bit in a section later. But first, here are some of the zones below the plant roof structure. These areas are for the collection of ash and liquids. The left image shows the late stage filtration before it's exhausted, and the right shows the chillers, and through the skylight you can see the chimney above. So in this section diagram we can explain how the plant works a little bit better. The trucks arrive from the left, where they tip the trash into a bunker. It's picked up by a gantry crane that mixes the trash and lifts the waste into the incinerator. The waste burns at about 1100 degrees Celsius, and the heat is transferred in turbines. Exhaust is filtered through many stages before it's ejected into the atmosphere. We designed the facades of the project from the geological forms and patterns of the mountain. We like landscapes. The guest-oriented programs protrude through the facade connected by a catwalk. Much of the facade is designed as a porous mesh or perforations to allow for the correct amounts of airflow to reach all the right parts of the plant. Here you can see the transition of the facade materials and their transparency. The base is made up of a graphic pattern derived from mountain ranges, and it's rendered in cast concrete panels. The middle sections and operable sections are made up of metal mesh of varying opacities. The top section is perforated aluminum panels simulating a snow-capped peak, and the chimney itself takes on the shape and coloration of a snowy mountain spire. BAM did a great deal of study to design the roof structure to withstand loads suitable for large canopy trees. Here we are in the studio studying a model, coordinating the functional openings with the design of the roof. We were able to work with engineers at Arup to come up with a frame solution and decks that met the many requirements of the plant below to be able to design the top landscape layer. The landscape is being installed as the project nears completion in 2024. The Baoshan Waste-to-Energy project was born from the concept of creating a recreational park as opposed to a waste plant. Ultimately, the project aims to attract future generations to this site so they can smell, touch, and see the role that waste plays in our planet's natural history. The next project I'm going to speak about is called a circular economy park. Thinking seriously about ecological balance, we learned a lot from Baoshan. Putting a WTE on the outskirts of the city is just not as good as getting it closer to the source. For Baoshan at optimum capacity, 150 truckloads arrive every day. Trucking the garbage is dirty and wasteful, and the transmission of power back to the city center is inefficient. In addition to the CO2 and energy loss, we break the cycle of the source of the trash and its recovery. We began to seek problems where we could position the WTE closer to the source. The benefits are huge. We found another operator trying to create a WTE for another site which is located within the fifth ring of Beijing. While this is not downtown, it is a central point of millions of residents, a good start to centralizing at a source. The site is an urban anomaly, a tiny infrastructural pocket of air, like a bubble in the system created by the curvatures of railways. In the urban plan, it could be considered a waste site, perfect for waste itself. For us, this was very interesting because The site had already been built with inefficient and undersized waste processing programs. The WTE could greatly improve the efficiency and the cleanliness. Plus, the waste heat from the turbines could be used to plug directly into the municipal heating system. We knew camouflage would be key. So we said, let's make this WTE fit into the surrounding railway context. Let's make it into a train hall. Our design of the plant utilized long span structures of railway halls to create a plant which from the outside may appear as a museum or a railway center. The exhibition and guest programs are brick, like some of Beijing's best museums. And viewed from the surrounding roads and rails, the roofs appear as long train sheds. Now, the best part, the landscape. We designed the WTE architecture to plug into a new axis we carved through the plot. A small campus of offices connects to the axis. These are intended to be leased to innovative companies focused on solving the problem of waste. Floating Exhibition Center gives resident businesses a common show space and meeting point, and the axis terminates in a sports park built over the former landfill site. We bring in the groundscape and the middle layers to reinforce the spatial design, and finally the canopy layer of the trees. And we arrive at a trash supercenter. Here, trash is a resource sorted for reuse, recycling, and energy extraction. Office and workshop spaces are created to foster creative companies working on waste problems. And then the whole thing stopped. We literally ran into protests. Nearby residents had learned about the project, and they were very concerned about the proximity of the waste to their homes, and for valid reasons. In this case, people were actually brave enough to protest the project. At this point, it was not really possible to communicate why the WTE is actually better than the current outdated waste management happening at the site. People hated the idea of this in their backyard. We had reached the point that locating the WTE in the city center is not only a technical problem, but also a messaging problem. And this is why design needs to play a role in the waste problem. Sanitation engineers are not trained to deliver compelling messaging, as designers are. When people protested locating a WTE within the fifth ring of Beijing, we said, okay, you don't like it there. Fine. We're going to try to put it in the center of the central business district then. This brings us to our third project, which is entirely theoretical, a waste-to-energy skyscraper. We need to stop thinking about waste as something to ship off to a landfill. We need to push the waste back into the architectural density from which it originates. We found some academic work on this topic where the waste-to-energy components are configured for stacking, and we got to work. Based on our understanding of the China code and requirements, we worked with an engineering intern from MIT to stack a WTE, and we developed a stacked three-line plant prototype. We picked a site in an existing coal-fired power plant, which is decommissioned. The site is located within the two most populated zones of the district. But more importantly, the site has been designed as the future of the central business district, home to gleaming skyscrapers. So we took our stacked three-line plant and inserted it into the new business district model. I am showing you this image because it represents the limit of engineering. This is as far as the engineer could get in the problem. It is an incredible accomplishment. But to make this a compelling argument, we needed designers to create a vision for this idea. So we got to work making a building to hold this baby. On the left, you can see some of the sections where the WTE plant is in gray. And here are some of the basic floor plate types, from the WTE plant to the office floors to the roof garden on the right. This project represents our negotiation with the public. We all wish for waste to disappear, but unless we actually confront the dirty problem, we will never develop a sustainable relationship to waste. To think about it another way, we are landscape architects trying to design the waste out of the landscape fringe, trying to push it back into the architecture of the city core. If the waste we produce is dealt with at hand, if we see it as a gleaming edifice, and we hand our trash almost directly to the machine of the WTE, will we start to develop a healthier connection to our waste? Will our city become more natural by processing its own waste? I want to conclude my talk today by returning to Central Park. I want you to take a good look at its vast size. And now I want to fill it with trash. This is the estimated waste that the entire world produced in the year that Central Park was built. Look at these tiny buildings. This is the total global municipal waste after it's been compressed for 2024. Those were only single years. If we want to look at the waste produced since Central Park was constructed until today, it towers into the thermosphere. The problem of waste will not be solved in isolated efforts. It will not be solved by quixotic landscape architects, nor will it be solved by sanitation engineers alone. However, I hope this talk has encouraged you, the landscape architects of India and Asia, to consider the roots of our profession in solving humble and maybe dirty problems. And I sincerely hope that we can work together to develop noble solutions to these very worthy problems. Thank you all for listening, and I look forward to our discussion.